Okay, next up. So with a geometric sequence, the explicit formula is going to look a little bit different than it did for the arithmetic sequence. That's because it's got a different pattern to it. So let's consider this sequence. I want us to think about, as I turn the lights back on here, how we get from term to term. So the first term is really just 3. So this was my first term. For the second term, to get from a 3 to a -6, we multiplied by a -2. So the second term was 3 times a -2. Now, from here on out, to get to the next term, we just keep multiplying by that same common ratio, by that -2. So the next term is going to be this one times another -2. -2 times another -2 is -2 to the second. If we do that again, and that's a times dot there, in the fourth term, it's going to be that starting 3 times the -2 3 times. There's a pattern starting to emerge. Each term has the first term, the 3, times the common ratio. But notice the second term only has the common ratio once. So the second term has it once. The third term has that common ratio twice. The fourth term has that common ratio 3 times. Each term number has one fewer common ratio multiplication in it. And that's why our explicit formulas are going to look like this. So here's how your textbook would write it. The nth term is simply your first term times the common ratio to the n-1 power. Because when you multiply again and again, you get exponents. That's where they come in. So the third term is going to have a power of 2. The fourth term, 4 minus 1, is going to have a power of 3. Just so you know, it is going to look slightly different. On the practice sheet, it's the same thing. So T of n in your textbook is written as A of n on the practice sheet, A sub n. T1, the first term, is simply A sub 1 on the practice sheet. Means the same thing, just means the first term. So with that in mind, I would like us now to take these formulas, write the explicit formula, and then find the specified term. Here's how it goes. So first off, let's get our common ratio here. So the common ratio is going to be bottom divided by top. So second term divided by first term. There's your common ratio. So the formula is pretty straightforward, I hope. So let's notice it's a practice sheet notation. So I'm going to use the practice sheet notation of the formula. So the nth term is the first term, which is -4, times the common ratio, which is 3, to the power of n-1. So this will always say A sub n. This will always say n-1. All that changes from case to case is what number goes here and what number goes there. Here's the great thing about this explicit formula. Just like with arithmetic sequences, once you've got this, it's very easy to find a specific term then down the line. So the 12th term is -4 times 3 to the power of 12 minus 1, which is 11. So this is going to be a big number. Over to my calculator here. I'm actually going to use my handheld calculator as well, so I don't have to keep going back and forth. So, reminding myself, it was -4 times 3 to the 11th, -4 times 3 to the power 11. Woo! Very big, very big. So that 12th term then is the number -708,588. When it's that big, I like to put a comma in so it's easier to read. So notice we were supposed to do two things: find that explicit formula and find the 12th term in the sequence. Okay, quick pause. I would like you to please go again. Find the explicit formula, and this time the 9th term in the sequence. Okay, let's start with that common ratio. So second term divided by the first. Common ratio this time is a -4. All right. The first term is just -2. So my explicit formula is the first term times. Now notice this time I put the times dot, and now here I'm not, whichever makes you happiest. I like to not put it in sometimes. That way you don't accidentally think it's a decimal. So more often than not, I'll write it this way. There we go. First term in the front, common ratio in the parentheses. So then to find the ninth term, -2 times -4 to the 9 minus 1, which is the 8th power. So I'm going to use my calculator here. -2 times -4 in parentheses to the 8th power. And I actually want to show you how that looks as well here. So you would do -2 parentheses -4 to the power of 8. So you do need parentheses there around that -4. Okay, so -131,072, -131,072. So don't make that hard on yourself. Notice that the pattern's always the same. Whoops, and I highlighted too much on that one. I wanted to do just the ninth term and its value. So pattern's always the same. First term times that common ratio to the power of n minus 1.